Thanks everyone for coming. So a few years ago, my first job was an engineer at Meta Reality Lab. I wasn't building any of those like a super cool Quest product. My background was web developer and know some of the Android stuff. My comfort zone was rooted web technology, HTML, CSS, JavaScript, React, easy to ramp up. But in my spare time, I dreamed of bringing something like rich, immersive shopping experience into XR. Using camera on XR device to capture a dress I love in real life and wanting AI model analyze it, given purchase link so that I can buy it directly. I want to integrate the power of infinity spatial canvas, AI, and augmented reality in my small project. But in the reality, learning Unity and Unreal feel like climbing Mount Everest. Developing for Apple Vision Pro was complex. And that AI part, deploying those large model on device, especially while protecting my privacy, not leaking my camera data, is another challenge. So I gave up. But that frustration sparked a question. Why can't a web developer or a native developer like me just writing a website and direct build a 3D spatial apps? So good afternoon, everyone. I'm Ruoya, a product manager from PICO's. The two developer tools I will introducing today are designed to ensure that when you have a brilliant XR application idea, you won't be held back by technical hurdles. So I'm honored to discuss with you how we are making it happen through two projects, WebSpatial and SpatialML. Together, we will explore how we empower developers, bring web and AI to spatial. Cool, let's start with some big picture of my talk. First, our team is heavily contributed to an open source project, WebSpatial. Secondly, I'd like to briefly introduce one foundational tool we published, SecureMR, which under big picture of SpatialML. WebSpatial is all about accessibility. It lowers the barrier of millions of web developers to build spatial experience using tools they already know. And SecureMR, on the other hand, focus on enabling powerful privacy-preserving AI and ML complexity of XR environment. It allows developers to bring intelligence into immersive experience without concern about user privacy. So together, those two tools aim to make XR creation not only more intelligent, but also far more inclusive and scalable. Let's take a look at, talk about WebSpatial and take a look at a short video about it.
For decades, the web was flat, efficient, but two-dimensional. Now, computing is entering a new era. Spatial, immersive, layered on the real world. Most developers build for the web, but XR? It's felt locked away. WebSpatial lets you use what you already know, HTML, CSS, JavaScript, and build spatially using Tray. Tray is your AI dev partner. Type a prompt and get clean code, ready to spatialize. You've seen WebXR demos before, but they don't scale, and with no App Store gatekeeping. WebSpatial is an open source framework for building modular spatial websites, not games, but apps you can interact with, like any modern web experience. It's cross-platform. Build for Vision Pro and roll out to Android XR. Even mobile and tablets. Get ready for AR glasses now. WebSpatial is free, transparent, open to all, and not owned by any platform.
Okay, so to understand the way initial and keep contribute to WebSpatial, we first need to look at the challenge in today's XR ecosystem. So the first challenge that XR facing is that XR development remains expensive and complex, especially for those without deep 3D experience. And even when developers manage to build something, the distribution opportunities are limited. Without strong cross-platform support or monetization pathway, there's little incentive for broadened adoption. You may be wondering, does the WebXR resolve the issue? The answer is no. WebXR primarily addresses distribution limitation, but still rely on specialized 3D development technologies, requiring developers to learn new things rather than leverage their existing 2D web skill. So this is where WebSpatial comes in to lower the barrier and open up XR creation to the broader web developer community. And another interesting point I would like to bring up is the power of the web. Sure, we have seen waves such as like search engine era that around the 2000, recommendation algorithms start from 2012, and now generative AI, right? But after years in this industry, I keep coming back to 3 timeless truths. First, developers always want tools that are simple and low barrier. Business always want to build apps or distribution channel fast and cheap. And user always want a product, a tool, or an app that are easy to use, no install needed. So, and guess what? The web still deliver all 3. That's another reason why our team is highly interested in web technology. So I have a question, like how many of you have done web development? Raise your hand. Nice. So how many of you have done native like iOS or Android development? Okay, fewer. Unity, yeah, I think like since it's an AWS conference, I expect more Unity than Euro like developer community. So like if we want XR to scale, we have to meet developers where they already are. Let's take a look at this chart. Only a tiny fraction of developers, less than 1%, are building with tools like Unity or writing low-level native code. These are the traditional 3D game or native app developers. But on the other end of this chart, over like 60% of developers today are web developers, mostly using JavaScript, React, HTML, and CSS. This is a massive untapped community where it comes to XR. Reading data from many sources, we did deep research on the market. Over 200 million active websites compared with 4 million native apps in this world. It's 15 times than native. What WebSpatial does is bridge that gap. It allows these millions of internet software developers to start creating spatial experience without needing to become 3D graphic expertise or learn a complex new, completely new engine. Just like React Transfer Web UI, we believe WebSpatial can democratize spatial UI creation. That's why we're not just focus on Unity or native pipeline. We are contributing to tools for the next wave of creators. Okay, now let's explain more about how WebSpatial empowers spatial creativity and expand your web from 2D to 3D. The first power that WebSpatial provides is split the web page and free your UI. Traditionally, web pages are flat, crowded, and boxed in a heavy frame. With WebSpatial, we can break the page apart. So you can say like every part of the interface, whether it's a chart, a video player, can become a free floating translucent panel that hovers in your real environment. And this lights the UI breath. It moves unnecessary border, and suddenly your component feels like it belonging in the space. And the second power that WebSpatial provides is elevate HTML element and unlock depth dimensions. So HTML elements have always living in 2 dimensions, X and Y. But what happens when you give them Z? With WebSpatial, you can move any element off the page, rotate it, scale it, bend it, and position it in 3D space. It means depth is no longer an illusion. It becomes a real dimension for your interface, make your content more immersive. Next, we are enable 2D web developer do multi-thing containers and able to make your website looks like a native app. This is an in-house first-party app we made using WebSpatial. The UI is exactly the same as a native Swift UI, right? So one of the biggest unlocks in spatial computing is the ability to compose your app from multiple windows or containers. WebSpatial lets you define those containers directly in code. Some can be a traditional 2D web window, other is fully volumetric. And the OS manage them natively, give you performance, consistency, and the same multitasking power as native apps. You're still coding with web, but just running like it belongs here. Lastly, what if your web app isn't just a layer, but truly 3D? WebSpatial lets you embedding actual volumetric content right next to your regular HTML. A 3D model spinning beside your checkout form, a real-time simulation running inside a dashboard. These elements blending naturally with 2D. You control layout, interactive, animation, or powered by your 3D engine of choice. It's not a web app anymore. It's a spatial app and powered by the web. So what makes WebSpatial such a developer-friendly open source project? First, you start with what you know. And second, it's cross-platform from the start. We currently support Apple Vision Pro today, and the Android XR and Pico OS are on the way. Thirdly, you don't need to rewrite. WebSpatial is designed to plug into your existing React project. Just drop in the SDK, use a few spatial APIs, and suddenly your web app gains 3D capability, like without modifying a lot of your code. And here is some real examples that use WebSpatial to build XR experience by Fluid. So Fluid is one of a WebSpatial early adopter, a remarkable team pushing the boundary of spatial computing. Fluid is currently the top-rated spatial multitasking app on MetaQuest. Their plan for uniquely allow users to seamlessly combine web-based application and streaming service in a mixed reality environment. What's truly impressive is how efficient Fluid leverage WebSpatial. They successfully transferred their new smart TV interface, which is built with Next.js and React, into 3D spatial media app in just a single afternoon. So it's a powerful testament to WebSpatial's capability and easy of integration. And also, Fluid founder is here today. So if any developer are interested in talk with him about the experience using WebSpatial, do you want to wave? Yeah. Oh, okay. And then, yeah, feel free to talk with them. Yeah. Curie is another example to realize their innovation collaboration with WebSpatial, focus on smarter, more immersive shopping. Curie fixed a key in e-commerce issue by getting rid of made-up information in AI product description, which builds back consumer trust. On our side, WebSpatial empowers customers to step inside the store. It allows them to explore products in 3D with real-time accuracy, offering a truly interactive experience. When you bring these two innovations together, Curie and WebSpatial deliver an immersive shopping experience that is not only fast and intuitive, but fundamentally built for convention. So it's amazing for how we engage with the product online. And also, Curie's founder is also here, and any developer want to discuss the experience to use WebSpatial, feel free to reach out. So here is another in-house demo we made with WebSpatial, where we bring the shopping experience to the immersive world. So are you ready to truly innovate beyond the screen? Scan the QR code, join the WebSpatial community on Discord today, and start building the immersive web with us. Okay, next, let's take a look at the SecureMR.
Mixed reality gives us a new way to understand the real world. Cameras enable intelligent labeling, mapping, and gameplay. But not everything should be shared. Some objects reveal personal health data. Others reveal your identity. SecureMR protects this data in real time. SecureMR runs in a secure system-level service with on-device inference using NPU acceleration, privacy-first mixed reality. Only on Pico.
Cool. Thanks. SecureMR is under SpatialML umbrella. There are many developer tools we can make under SpatialML, from AI data collection, model training, and model deployment to make AI empower the XR world. Today, I would like to specifically introduce one of our framework called the SecureMR. Like, what kind of problem is SecureMR is trying to resolve? Let's also take a look at the MR deployment challenge we made today. So first, the privacy-sensitive data processing is a concern. Developer wants to add AI feature to XR, things like intelligent interaction or things understanding, but they are also concerned about privacy and local data protection. Secondly, there is increasing demand of AI ML powered feature in XR, and there are a lot of different size big model that are different functions. How to integrate those AI models smoothly into usage of XR increase a bar for developers to use AI in XR. Thirdly, deploying the model is already a challenge. How can deploy leverage cutting-edge AI while respecting user privacy? So SecureMR is designed to solve all those problems. Oh, sorry. So firstly, SecureMR enhances security for sensitive data. It empowers developers to build AI-powered XR apps while still respect user privacy. Secondly, it simplified ML implementation. Since SecureMR abstracts the complexity of lower-level ML, make AI integration more accessible to developers. It also provides tools and SDK to streamline the process of ML model into MR environment. And also, it's easy to use, like AI model integration. It's directly providing the result to the developer, but not sending back the user data to the developer. Fourthly, it's empower developers with secure AI. SecureMR empower developers to create innovation and privacy-preserving MR application that leverage the power of AI. This is a facial recognition model we deploy inside of our SecureMR pipeline. So you can imagine it's very easy for us to use SecureMR to make a live facial sticker when you watch someone through an XR device. And here are two other demos we made through SecureMR. The first one is the object detection model. Through SecureMR, we deploy object detection model in the pipeline. So when you look at the real world, it can recognize the object you look at. Similar story about second demo. You can easily detect person's movement by just deploying an AI model into SecureMR. It can return the data you want to build your app without giving up any privacy data from the camera. Now, you may wonder how we achieve this goal through SecureMR. On the right side, you will see an architecture diagram of SecureMR. So let me quickly walk through it. At the top, we have the application layer, which sends both a model and inputs like video, depth data into SecureMR runtime through an API. Within SecureMR, the model is located into the feature model module. Then it's run through the interface engine. You will notice there are two types of input. Explicit input like camera image or user gesture. Implicit input such as device, orientation, lighting, or context signal capture. Once the model runs, the output such as classification result, coordinator, or segmentation map are sent to the secure command engine. This layer determines how those outputs should affect the app. Whether it's render an UI element, triggering an animation, or adjusting virtual content placement. The render context handle the final visualization, and the output sent to the video see-through layer to appear in the user's XR view. So you can imagine of an AI-powered virtual whiteboard that responds to hand gesture, but without sending your hand data to the cloud. So as we look towards the future, our vision of spatial ML goes beyond one on-device inference. We are building towards a more intelligent and intuitive XR environment, one where AI enhances not only perception, but also interaction. So also please join our Spatial ML Discord channel to learn more about SecureMR and talk directly with our engineers. Okay, this is my end of my talk, and I can answer questions, and yeah.
Questions, anyone?
Yeah, please.
So the WebSpatial is kind of a standard, but do the browsers need to integrate something, basically to extend the WebXR standard, or is it some kind of a really clever wrapper around it?
So your question is like, is it related to WebXR? Like?
Yes, correct. Like when I want to use WebSpatial, then you say it's more like a plug and play.
Yeah.
Yeah, but do the browsers actually need to integrate something for that, like a proposal for a standard, or how does it work under the hood?
So basically, you can, it's a SDK, so you can download, integrate in your project. And it's nothing to do with like WebXR. You can use HTML, CSS, you write your 2D web, and you add some like spatial tags, like HTML tags in your project, and then it can run, it can specialize your 2D web.
Cool, thank you.
Yeah, and also like if any developers want to ask a question to Fluid or Curie founders, like, yeah, please, because they have experience using our project, yeah, our SDK, yeah.
So we really enjoyed our experience using the SDK as it is, and I'm curious if you can talk a bit about the roadmap for the next few months with where it's going.
Yeah, very good question. So in the next few weeks, like we are going to officially launch with you know, like right now we're in the beta testing, and in this quarter we're trying to support the basic function on Android XR. And by the end of this year or the beginning of next year, we're going to support Pico OS, and then support the Meta Quest. Yeah, so it's a rough roadmap for our WebSpatial. Yeah.
I think we are at the time, but
oh, okay.
Time for a very quick question.
Sorry, I'm not in a good position for I have a quick question on WebSpatial. Is it possible to also get a WebGL or a WebGPU context in a WebSpatial application, so you can have obviously the HTML elements rendered into 3D powered by WebSpatial, but then maybe also have other objects with interesting like shaders and those sorts of things running at the same time?
Yeah, it's possible because we will support 3D content in next 2 quarters, and we will create a 3D volume. Inside of the volume box, you can play around with WebGL and all the things you mentioned. Yeah, but it's also integrated. You can very good integrate with your 2D web stuff as well. Yeah. David, do you? Okay.
Okay, thank you.
Give it up for Ruoya.